So this video is about angles in polygons. So as you know, a triangle has 180 degrees in it, trekant in Danish. A quadrilateral, vierkant in Danish, that's any four-sided shape, so not necessarily a square, but anything with four sides has 360 degrees. And in fact, you can take a four-sided shape and split it into two triangles. Then if you think about the two triangles having 180 degrees each, and all of the angles in the triangle are around the edge, so they're also angles of the quadrilateral, then you can see how a quadrilateral can be split into two triangles, and so 2 times 180 degrees makes 360 degrees, which is a way of seeing how the angles in a quadrilateral add up to 360 degrees. So pause the video and just write all of that down neatly in your books. And then when you've done that, restart the video. Okay, so moving on now, assuming you've written that down. So we can think about a five-sided shape, a pentagon. A pentagon adds up to 540 degrees if you look at all of the internal angles. And again, you can take a pentagon and split it up into, this time, 3 triangles. So as long as you start at a particular point, and then just make your triangles radiating out from that point, then it ends up with all of the angles being around the edge. So all of the angles in the triangles you make are also angles in the big pentagon. So you can think of it as 3 triangles, 3 times 180 degrees, which gives you a reason why a pentagon should always add up to 540 degrees. So we can split a pentagon into 3 triangles. 3 times 180 degrees equals 540 degrees. Well, you could do that with 6 sides. So add another side and it would make another triangle. And there it is, a hexagon. So something with 6 sides. So as long as you're drawing all of your triangles from one point, because of the extra side, you can make an extra triangle. So out of a hexagon with 6 sides, you can make 4 triangles. And because of the angles in those triangles all being around the edge, then they're also angles in the hexagon. So the hexagon adds up to 4 times 180 degrees, 720 degrees. So again, pause the video, take a note about that. Then here's one more example, a heptagon. So this time it's got 7 sides. So it's got one more side than before. And because it's got one more side than before, we can make an extra triangle out of it. So again, starting at a point, just making triangles radiating out from that point. And as long as we do it that way, then all of the angles end up round the edge. So all of the angles in the little triangles that we've made are also angles in the big heptagon. So therefore a heptagon has 1, 2, 3, 4, 5 times 180 makes 900 degrees in it. So you start to notice a pattern here. However many sides the thing's got, the number of triangles you can split it up into is always 2 fewer than that. So 7 sides split into 5 triangles, 6 sides split into 4 triangles, and that's because every time you add an extra side, you can make an extra triangle. So pause the video, get that written down. And there's the observation. Generally, the number of triangles that we can split the shape into is always 2 less, or 2 fewer, I should say, than the number of sides. So a 20-sided shape would split into 18 triangles. So if you had to figure out what the angles in a 20-sided shape add up to, it would be 18 times 180. That's 3,240 degrees, because 20 sides splits into 18 triangles. Each triangle is 180 degrees, so 18 times 180 degrees makes 3,240 degrees. So jot that down neatly in your books, pause the video while you do that, and let's move on. So this leads you to a formula that the angle sum is 180 times n minus 2. So there's no symbol saying times between the 180 and those brackets, but when it's written like that in algebra, it's sort of implied. So when n is the number of sides, the angles add up to 180 times n minus 2. And that's because you've got the number of sides, you take away 2, and that gives you the number of triangles that it'll split into. And then each triangle is 180 degrees, so that times 180 tells you what the angles all add up to. So pause the video and take a note of that neatly, please. And there's the questions about this. So what do the angles add up to in a decagon? That's a 10-sided shape. And then if the decagon has to be regular, how large will each angle be? So regular means all the sides and angles equal. Well, have a go at that question before you continue the video. So pause the screen for now, have a go at that, and then carry on with the video when you either think you've done it, or if you're completely stuck and you want to go straight into the explanation. Okay, so here we go. So the angle sum is 180 times n minus 2. That's the formula. So here we've got 10 sides we're talking about for a decagon. So we stick 10 into that formula, and then the angle sum is 180 times 10 minus 2. So that's 180 times 8, which is 1,440. So the angles in a 10-sided shape, a decagon, would add up to 1,440. And if they add up to 1,440, and then there's 10 of them, and you want it to be a nice regular shape with all those angles the same, then 1,440 divided by the 10 angles would be 144. So a nice regular decagon, a 10-sided shape, would have 10 angles of 144 degrees. And then we can draw it. Well, a top tip for drawing that, instead of trying to do lots of 144s and measure them, if you try and do that, you'll almost certainly end up with something that doesn't quite meet up when you get back round to the beginning. So instead of doing that, a little bit of a cheat, draw a circle, split it into 10 by doing 360 degrees divided by 10 makes 36 degrees. So just split the circle into 10 parts, 36 degrees apart, and then join those parts up with straight lines to get your decagon. And then just check afterwards that the angle you get in there is indeed 144 degrees. That'll just give you a more accurate way of drawing a decagon, a regular decagon, without errors. If you try and just draw lots of 144 degree angles, they'll probably not meet up at the end. You'll probably be about half a degree out on each one, just because of the thickness of your pencil, and it won't quite meet up. So here's a similar question. What do the angles add up to in a dodecagon? That's 12 sides. And then if the dodecagon has to be regular, how large will each angle be? So again, pause the video while you attempt that. So assuming you've attempted that, let's move on. Okay, so the dodecagon angle sum, well, the general formula is 180 times n minus 2, where n is the number of sides. So just stick 12 in that formula for 12 sides, and you get 180 times 12 minus 2. So that's 180 times 10, which is 1,800. So if you've got a 12-sided shape, the angles will add up to 1,800. And then if you want to draw a nice regular one, so each angle will have to be 1,800 divided by 12, because there's 12 sides and 12 angles. That would give you 150 degrees. So if you want a nice regular dodecagon with 12 sides, and all of the angles have got to be 150 degrees. And you can draw it. So again, my little life hack here, instead of trying to draw it and make the things join up, draw a circle, split it into 12 like a clock face. So 360 degrees divided by 12 means you get 12 chunks that are 30 degrees each. So you draw your 12 slices 30 degrees apart, and then you join them all up with straight lines. I've done it in purple, and that gives you your dodecagon, your 12-sided shape. And then you can check afterwards that the angle in there is indeed 150 degrees. So you can generalize that idea into a formula. If you want to know what each angle is in a regular polygon, so not the sum of all the angles, but just each individual one, you take the number of sides minus 2, that gives you the number of triangles you can split it into. Each triangle is 180, so you multiply by 180 and you get the total of all the angles. So the top of this fraction here is the total of all the angles. And then if you want to know what each angle is, then you need to divide by how many sides and therefore how many angles there are. So divide by the number of sides gives you the formula for each angle in a regular pentagon. So if I want to know what each angle has to be in a regular pentagon, for example, so I mean this formula is for a polygon generally, but if I want to know it for a pentagon, that's 5 sides, then I stick 5 in there, and sticking 5 in there for n, and working out what that all comes to will give me what each angle in a regular pentagon would be. So take down this note. We can generalize this idea into a formula. Each angle in a regular polygon, any number of sides, equals 180 times n minus 2 divided by n. So n is just the number of sides, and the top of this fraction gives you the total of all the angles, and then the bottom of the fraction you're just dividing by the number of sides, which is also the number of angles. So pause the video and make a nice neat note of that, please. And there's a question for you. What is the size of the angle in a regular 20-sided shape? So if you want to draw a nice regular 20-sided polygon, how many degrees will each of the 20 angles be? So pause the video while you have a go at that. And here's the answer. So the general formula for each angle was 180 times n minus 2, number of sides minus 2, and then divide by the number of sides. So we just stick 20 into that formula. 180 times 20 minus 2 divided by 20. So that's 180 times 18 divided by 20 comes to 162 degrees.